Welcome to IAC Acoustics webinar on sound absorption systems for industrial and outdoor applications. My name is Dan O'Brien, and I'm IAC's Commercial Industrial Sales Manager, and I'll be presenting the webinar to you today. Please take a moment and just jot down my contact information that's on the screen right now. And if you have any questions that we don't get the chance to cover during this webinar, or if you'd like a copy of the presentation, please feel free to email me or give me a call and make a request, and I'll be happy to provide further assistance. First, a couple of notes about myself. I've been involved in acoustics and noise control for over 20 years, including working for IAC Acoustics in the past, actually, as well as SoundSeal, Owens Corning, and the Aero Acoustic Corporation. Currently, my role with IAC Acoustics is to support acoustical consultants, architects, engineers, designers, and IAC Acoustics reps and product resellers with application support and product information for IAC's industrial line of products. Our industrial line of products includes outdoor barrier screens, sound control enclosures, sound absorption panel systems, and then also silencers and acoustical louvers for HVAC noise control applications. In this presentation, we're going to cover some IAC Acoustics background information. We're going to touch very briefly on some basic acoustics and sound absorption panel terminology. We'll talk about the different IAC noise foil panel types and performances and applications. And then I'll also show you on IAC's website where we can find additional information that you might have, that you might find helpful. I also want to let you know that I'm monitoring the chat and question applications for the GoToWebinar session. And if you have any questions about what we have up on the screen, or you'd like me to go into further detail, please either just raise a hand to ask a question or shoot me a message on the in-webinar chat, and I'll make sure that we try and get it addressed while we're in the webinar before we wrap up. We'll be on the webinar for about 30 minutes, just to let you know. Okay, so first, let's start with IAC Acoustics. IAC was founded by Martin Hirschhorn in 1949 on Jackson Avenue in the Bronx, New York City. His first projects involved noise control for apartment building developers in New York City. So he was focused not necessarily on the tenants of the apartments, he was focused on the building owners and the building developers, the people who are designing and then selling or renting out the units. And everyone in the real estate world at the time quickly learned that tenants valued quiet and they valued privacy. And if you're building apartment buildings in New York City, that's a difficult thing to do. So Martin's first projects really involved finding ways to isolate apartments from exterior noise and also from noise coming from other units. That was an incredibly lucrative opportunity for him. And IAC grew continuously until it became a very large facility with a lab in the Bronx. Martin sold the company in 1998 and retired in 2001. Currently, IAC Acoustics is a division of Catalyst Acoustic Groups, and we're part of an elite family of acoustics, noise, vibration, and seismic control companies that, when you look at what they offer as a combined unit, they offer the broadest portfolio of solutions that's available in the market today. IAC Acoustics team includes myself, Tom Hines, IAC's director, Ted Marquis, the industrial sales manager that covers in-plant and product test applications, Darren Riley, who manages IAC's HVAC noise control business, and then also Nick Smith, who specializes in dyno room applications and motorsports applications. IAC sound absorption panel systems protect workers by reducing the reverberant buildup of sound energy within enclosed spaces and reducing unwanted reflected paths in outdoor applications. Within enclosed spaces, people are exposed to both direct sound energy traveling directly from the source to the receiver, and then also reverberant sound energy that reflects off of one or more surfaces before reaching the receiver. Some common surfaces, such as floor tile and concrete and roof decks, provide only minimal sound absorption, and there's very little reduction in the sound energy as it repeatedly reflects off of these surfaces. Reverberant buildup of noise in confined spaces can actually increase the sound pressure levels by 5 to 10 dB, which can create unsafe conditions for workers and also interfere with communication. By adding sound absorption into the space, we can greatly reduce or eliminate this reverberant buildup. In larger enclosed spaces, reflected noise and reverberant buildup is also an issue. In larger enclosed spaces, sound energy from a source at one location can travel throughout the facility and raise background noise levels far away, so that they interfere with communication and productivity throughout the facility. In large manufacturing plants, this can be a particularly difficult problem to solve. But adding sound absorption can minimize the undesirable contributions of the reverberant sound path. The most common locations to add that sound absorption are typically the underside of the roof and walls. Reverberant and reflective sound energy is also a problem, or can also be a problem, in outdoor applications. Outdoor noise problems are frequently addressed with acoustic barrier screens. For example, sound barrier walls along roadways are intended to protect neighboring communities from traffic noise. However, the presence of reflective surfaces, such as retaining walls or large structures, can reduce the effectiveness of the barrier wall. The reflective surface can redirect sound over the top of the barrier wall, as we've shown in this sketch on the screen right now. Adding sound absorptive surfaces to the reflective structure can improve the effectiveness of the screen and avoid unexpected problems. We're going to talk a little bit about the properties of sound absorptive materials and how they're rated and how they're measured. The sound absorptive properties of a panel or material or system will typically vary by frequency. One measure of the sound absorptive property is the sound absorption coefficient, which is typically shown at various frequencies. The sound absorption coefficient can be thought of as the percentage of sound energy that's absorbed by the component, and it's typically shown as a decimal. A sound absorption of coefficient of 0.85 in the 250 Hz octave band represents absorption of about 85% of the sound energy in that frequency band. Because there are several different frequency bands, and sometimes it's useful to have a single number rating of the overall sound absorptive properties of the material, the noise reduction coefficient, or NRC, can be used. The noise reduction coefficient represents an average of the sound absorption coefficient values from 250 Hz to 2000 Hz. The sound absorption coefficient and the NRC are tested and calculated according to the ASTM C423 test method. The test consists of using a reference source in a highly reflective interior room called a reverb chamber. The reference source is played inside the reverb chamber, and a microphone is used to measure the sound levels inside that chamber at various frequencies. The same reference level is then played, and the same sets of measurements are made with a sample of an absorptive material in the room as well. The difference in the measured sound levels, with and without the sample present, can be used to mathematically evaluate the percentage of sound energy that's absorbed by the sample. Because of edge effects, the fact that some samples can exhibit some absorption on the edges, the perimeter of the material, and also because sometimes the dimensions of the sample as well as the dimensions of the room may not be different enough, the math that's part of the standard can actually produce results that are counterintuitive. Sometimes the results can be greater than 1.00 or theoretically greater than 100% sound absorption. In reality, the materials will typically not absorb more than 100% or even really come close to absorbing 100% of the material, but we report the numbers that were given by the lab measurements. IAC Acoustics produces several different types of sound absorptive panels, and each of them has their own purpose and their own application where they work the best. All of the sound absorptive panels consist of a perforated metal face sheet in front of an acoustic glass fiber absorber. The panels are available in a variety of thicknesses, and they're also available both with and without wrapped fill, and also with and without an acoustic spacer. Including each of those elements and changing the thickness of the panel can produce different sound absorption coefficient values and different NRC values. We provide a full set of lab data on our website and in our literature for both sound absorption coefficients and also noise reduction coefficients. We also include, for some of our panel samples, test data that reflects both continuous installation, where the panels cover a complete set of walls or ceilings, and then also intermittent coverage, where you may have a space of wall exposed, and then a section of wall that's covered by a panel, and then another section of wall that's exposed. This can affect the sound absorption data for the product, and we try and make that available with our panel systems so that acoustic consultants and designers can make an accurate choice as to how much material is required for a particular application. IAC sound absorption panels are called noise foil, and we have 5 different types of noise foil products. They're referred to as noise foil 1, 2, 3, 4, and 5. And the last type, the noise foil 5, is specifically designed for permanent exterior installations. It's also known as the Noishield Type CS cladding panel. You can see from the NRC values in the table that's shown that all of the panels are highly absorptive. The NRC values range from 0.7 to 1.3, and the sound absorption coefficients from 125 to 4K are also all very highly absorptive. One trend that you'll notice is that at the lower frequencies, there's less sound absorption. That's generally true. The other trend that you'll notice is that by increasing the thickness of the panel, in many cases, you're able to improve the sound absorption in the lower frequencies. One other trend that you can key in on while you're looking at this table that shows values for sound absorption coefficients and NRC with a polyethylene rapid spacer is that the polyethylene rapid spacer generally affects the sound absorption negatively. If you're looking for the highest sound absorption possible, in general, that's going to come with a panel that does not include either a polyethylene wrap or a spacer. IAC Acoustics noise foil sound absorption systems are available in a variety of shapes and sizes. They're also available in a variety of materials of construction, and they're available with a variety of finishes and mounting methods. We can supply panels made of galvanized steel, galvannealed steel, aluminum, and stainless steel. The aluminum, galvanized, and galvannealed panels can be provided either with a mill finish or with a powder-coated finish. The panels can be installed either continuously or intermittently, depending on the desired coverage, the appearance, and the potential for any obstructions at the site. One coating system that I didn't touch on here, but we can provide, and we have provided several times in the past, is a fluoropolymer finish. A fluoropolymer finish such as Kynar is incredibly durable and corrosion resistant. One advantage that IAC offers all of our customers over some of our competitors is that our panels are powder coated in the same facility where they're fabricated. The fact that we're powder coating and fabricating at a single site means that we can maintain tighter control over the schedule, and we can ensure that when the customers are looking for the panels to ship on a particular day to show up just in time for installation, we can do that. It's very hard and it's very difficult to coordinate delivery of materials if you have to fabricate at one location and then ship the components to another location for powder coating, and then try and control the shipping dates from that location. We can also supply, in addition to the panel system, a variety of mounting details: Z-track, J-track, standoff mounts, and stainless steel mounting clips. The attachments and fasteners can also be powder coated to match the panels. IAC Acoustics noise foil sound absorption panels are suitable for equipment rooms, and areas, pump stations, engine genset rooms, test facilities, manufacturing plants, compressor packages, or I should say compressor rooms and equipment halls, really a wide variety of industrial plants and facilities. I'm going to go through each of the different noise foil types right now and present some additional details and information. If anybody has some questions, again, please feel free to let me know. I'll be happy to try and answer them as we're going through the presentation. Noise foil type 1 panels are typically used for interior applications. They can be included as part of a new construction plan and specification project, where the reduction in background noise will help meet OSHA requirements, and it'll also help reduce noise transmitted to the property line. Typical applications include extensive coverage of walls and the ceiling. This is true for all of noise foil 1, 2, 3, and 4. Noise foil type 5, as I mentioned earlier, has been purpose engineered for permanent exterior applications. It's also suitable for both new construction and retrofit applications. The noise foil type 5, or Noishield cladding panel, includes a roll-formed section for exceptional flatness, a pitched upper surface, and a perforated lower surface to shed and drain rainwater quickly. The noise foil type 5 panel is powder coated on both sides of the sheet metal, providing full coverage and protection and maximum corrosion resistance. Noise foil 5 panels can be fabricated either with a G90 galvanized steel material, which provides superior corrosion resistance, or aluminum. Noise foil 5 panels are intended to be mounted to an existing solid wall, such as CMU or precast concrete. The pictures on this slide show several sets of noise foil type 5 or cladding panels attached to concrete walls surrounding a loading dock at a supertarget in Florida. Noise foil type 1 panels are our simplest panel to provide. They're an open-backed panel. They consist of a form perforated pan that's filled with glass fiber acoustical insulation. The left and right sides of the panel have a perforated edge, and then there's a perforated return on the back tab. Noise foil type 1 panels can be installed vertically or horizontally, and standard widths are 14 inches and 18 inches. We can provide these panels in a maximum width of 42 inches. Lengths up to and including 144 inches are available. Narrower widths will simplify the layout and installation and maintain a flatter face without the need for internal stiffeners. However, narrower widths will also mean that there'll be more numerous panels for the same surface area of coverage, which means that the installation may take a little bit longer. Alternate fastener methods can include screw holes in the front face of the panel, which will be covered up with plug caps. The screw holes in the plug caps allow a screw through the back tab directly into the surface to hold the panel in place. Noise foil type 2 panels are a slightly more complicated version. Noise foil type 2 panels are fabricated with a perforated sheet metal base and then a perimeter set of channels either on 2 sides or 4 sides to provide the required depth for the acoustical insulation. Noise foil 2 panels are intended for large area applications where there is a desire to reduce the amount of installation time and reduce the amount of panels that the installation team has to handle. Noise foil 2 panels also have greater stiffness at the edges, and they can be provided with internal stiffeners, pop riveted to the face sheet. Because these panels are typically much larger than noise foil 1, you're not going to get as flat an appearance, so they're more suitable for very industrial applications where the appearance of the panel is less critical. Noise foil tube panels can be installed with either J or Z track, or with an H joiner detail, or a removable H joiner detail. Noise foil type 3 panels take a noise foil 1 panel that has an open back, and they add a perforated back sheet to it. The perforated back sheet means that the panels could be suspended as baffles with perforated facing on all 6 sides, or they could be used as a sound absorptive panel with an airspace mount suspended from the ceiling. The advantage of the airspace mount is that you increase the effective absorption of the panel without adding additional materials. Noise foil type 4 panels consist of a noise foil 3, but in place of the perforated back, a solid back sheet is utilized. Noise foil 4 panels offer a very basic sound blocking capability of STC33. They're available in both 2-inch and 4-inch thicknesses, and they're suitable for applications where they form a basic sound absorptive panel that can be installed as a ceiling grid application. They're typically used where there is a desire for 4 inches of acoustical insulation for sound absorption, but there's also a desire for some minimum sound blocking capability. Perhaps if there's a concern that noise might intrude into the plenum space above a ceiling assembly, migrate along the ceiling assembly, and then transmit back down on the other side of a demising wall. This type of panel is an excellent choice for that type of application because it can contain sound within the space below it, but still provide superb sound absorption, certainly much greater than you would get with an acoustical ceiling tile material. The noise foil 5 panels that I mentioned earlier, also known as the Noishield Type CS, are really ideally suited for outdoor installation. The panels consist of a 2.5-inch deep hat shade section that's either 18 inches or 24 inches high. They're available in lengths up to 20 feet, and they're a very cost-effective way to add absorption to exterior sound reflective walls. The thickness of the panels can be increased from 2.5 inches by adding a standoff behind the panel. A 1-inch standoff will increase the thickness to 3 inches, and a 1.5-inch standoff will increase the thickness to 4 inches. For standoff applications, IAC can supply the standoff as well as the added insulation. We publish a full set of acoustical data for all 3 of those depths. And that's either a 2.5-inch, 3-inch, or 4-inch depth. And with the standoffs, the panel designation is either a type CS, or a C12, or a C38, with the 12 and the 38 suffix referring to the additional depth of the standoff in millimeters. You can see from this chart that increasing the thickness of the CS panel doesn't make much of a difference in terms of the NRC value. But when you look at the lower frequencies, you'll see that you pick up substantial sound absorption in the 125 and 250 hertz octave bands. This project would target and involve multiple stacks of panels on either side of the loading dock. The objectionable noise was coming from truck traffic and then also from the trash compactor. Noishield CS panels with a 2.5-inch thickness were added to the concrete walls. With an NRC of 1.00 and a sound absorption coefficient of 0.30 at 125 hertz, they reduced the amount of sound that was transmitted over the walls to the right and then across the property line beyond those walls into the neighboring community. One item that I really like to point out on this photo is that the reflections from the 2 tractor trailer trucks on the right wall really allow you to key in on how flat that surface profile is and how smooth the panels are once they're installed. Frequently, one objection that people have to noise control systems is that the appearance of the noise control measure kind of interferes with the appearance of the rest of the project. For this project, it was important to have a panel that blended in, and we were able to match the color scheme of the shopping center and provide very flat architectural looking panels for installation. IAC Acoustics has recently upgraded all of our literature, and we're publishing the same data, but just in a new format in our bulletins and our brochures. The bulletins and brochures include product instructions, formatted specifications, and data tables. All of that information is available on our website, iacacoustics.com. And sometimes websites can be a little bit tough to navigate, but if you go to the IAC Acoustics website, what you want to do is click on the industrial button. That'll open up a drop down below you. And then if you click on the noise foil absorption panel flyout, you'll be brought to the noise foil and absorption panel home pages. Those home pages include case studies, specifications, literature, and an IAC standard color chart. If there's any other information that you might like, or if there are any other questions that you have, now would be a great time. I'm checking out the questions tab and our chats to see if there's any other information here that attendees would like to have us cover. It doesn't look like it at the moment. So this will wrap up our webinar. And again, if anybody has any questions that come up, or if there's any other additional information that you'd like to have, please feel free to reach out. My role at IAC is to support designers, reps, and acoustical consultants with additional product information. So I don't need to have a specific product or a specific proposal to assist you. I'm more than happy to just help you answer whatever questions you might have. All right, well, that concludes our webinar presentation. Thank you very much for attending, and have a great day.